All right, last two problems in the exponential and logarithms section. So these are factoring problems, but they are disguised. And these couple are disguised pretty well because here you don't have 5, your 25 is not written as 5 squared. So what I'm going to do is go ahead and take my 25 and rewrite it as 5 to the 2x. Remember, 25 is 5 squared. And when you have power to a power, you can multiply those exponents. So I think that's a nice way to write it. You do have to have that written that way so that you can factor here. And we're going to use U substitution. So once this is nicely in that form where we have a squared term, a singlet, and a constant, your singlet is what you are going to make your U. So we're going to say let U equal 5 to the x. So 5 to the 2x is U squared. 5 to the x is U, so that middle term becomes 14u. And then we leave our constant alone. Let it be what it is. And factor. We need two numbers that multiply to 48 and add to negative 14. So those two numbers are 6 and 8. Both negative. Our answers are going to be positive, but they are negative since we're adding to a negative 14. Negative in our parentheses. So that means U equals 6 and U equals 8. On your exam, you're not going to see those as solutions because we're not done yet. You have to remember to substitute what your U was back in. So we said U was 5 to the x. So 5 to the x equals 6, and 5 to the x equals 8. In order to pull that exponent down in both cases, you can use log or you can use ln. Before you do that step, I would take a look at that multiple choice problem and see which one is in your final answer. I used ln on this problem on my exam review packet, so I'll go ahead and use ln on this video. Make sure you do that to both sides. Again, that lets you pull this exponent down. That lets us use the power rule. And remember, ln of 5 is just a number, so we can divide by it. You cannot condense that any further. You can find the approximate solution. Make sure if you're not using a fancy fraction that you put your 6 and your 5 both in parentheses there. Again, you cannot just make that ln of 6 divided by 5. Those are not equivalent. Ln of 6 is its own number. Ln of 5 is its own number. The quotient rule works for subtraction. 5 to the x equals 8 is going to work very similarly. X ln of 5 equals ln of 8. Divide both sides by ln of 5. Beautiful. That one's done. Similar work for number 15. 4 is 2 squared, and since I see what my exponent is connected to and my middle term is 2 to the x, I do need to change my 4 into 2 squared. And I need to bring my 21 over so that I'm set up nicely for factoring. In this case, again, I'm going to let U be this middle term. Well, the variable for the middle term. The singlet. two numbers that multiply to negative 21 and add to positive 4 are positive 7 and negative 3. That means u equals negative 7 and u equals 3. Again, don't forget to keep going. Negative 7 and positive 3 are not your final answers. They just help you get there. It's your middle step. So we said u is 2 to the x. Remember, with all our exponentials, there is no exponent that we can use and get a negative number out. That's not a thing that exponents can do. So 2 to the x equals negative 7 does not give us a solution. You could try to take the log of both sides, but you're going to end up taking the log of a negative number. And once you put that in your calculator, you'll realize that was a little bit of a waste of time because you can't take the log of a negative. Your calculator will give you an error. Since I used ln on the last problem, I'll use log base 10 on this one. Make sure you take the log of both sides when you're pulling that exponent down. When you are rushing a little bit, which you may do on the exam, if you freak yourself out a little bit, that's a thing that I drop sometimes that I have to be careful of. So I'm going to bring down my x. And then divide both sides by log of 2. Don't try to condense that guy any further. All right, that's your logarithm section of your semester exam review. I hope that you've enjoyed it. I certainly have.